Now we're going to look at some examples and talk a little bit more about some of the protocols associated with the IP protocol family. The first one we'll look at is Icmp, or Internet Control Message Protocol. Now, Icmp packets are probably used by every person who's ever troubleshot a network. They're usually associated with the ping command and utility or the traceroute command and utility. Now, what ping does is it's used to verify and troubleshoot connectivity and to make sure that TCP/IP as a stack is working properly. So you might ping your own local loopback address or ping the default gateway, and what you would get is hopefully a reply back that tells you that there is connectivity. All it is a series of packets sent out and returned, and if there's no return, then you know there's a problem with network connectivity. It's probably the most widely used troubleshooting tool out there used by network professionals. Now, the bad thing about Icmp is it can be manipulated. It can also be used to carry out denial of service attacks. Oversized Icmp packets and things like that can be used to bring down a computer. And later on in a session about malicious packets, we'll talk about Icmp and how it is used in carrying out these denial of service attacks. For right now, though, what I want to show you is just the Icmp packet and header and show you what kind of data is sent. I'm going to give you an example of what happens when an Icmp reply is not received, meaning there's no network connectivity, or it could also mean that Icmp is being blocked at the firewall or the router. And then I'm going to show you an example of an Icmp response where there actually is a reply. Okay, in our first capture, we're going to look at a simple Icmp request. Now, what I want to show you is, first, even when there's just a simple ping, there may be a DNS query that goes out because I asked the machine to ping www.vtc.com. So there was a DNS query that went out, and there was a DNS reply. So now I have an IP address because, remember, IP uses IP addresses. It doesn't use DNS names such as www.vtc.com. So before it could ping that address, it had to resolve it. So it sent out a DNS request and I got a DNS response back. So now we can start the ping process. So let's look at the first ping that goes out, the echo request. Let's expand our window up a little bit. And what we see is it's under the Internet Protocol. And again, we're seeing some of the same things we saw before. Version 4, the header length, services fields, the total length, the identification, the flags. There's no flags necessary. There's no fragmentation of an Icmp packet for this particular example. Time to live, and the protocol, which one's being used, Icmp, and the fact that the header checksum checks out. There's also a source and destination address fields. Now, since Icmp is part of the IP protocols, let's look at it. For the header for it, we see that there's a type 8. Now, there are different types of Icmp control messages, and this type 8 is a echo ping request. Okay, the checksum is correct. There's an identifier, a sequence number for it, and we also have data that goes with that Icmp header. And here's the data right here. And it's in hex, but if you look down here at the bottom pane, and you'll see the ASCII translation of this data, all it is, really, is the alphabet. So there is a piece of data that's sent out, just sent to the receiving computer, and the receiving computer should respond back. Now, in this particular example, we see the 4 requests, and sometimes if you see 4 requests, you'll know that by default that's a Windows box that sent that. Most Linux boxes will send a continuous ping. Windows by default will only send 4 at a time unless you also add the -T with that ping request. So we've got 4, so we know that's a Windows box, but we don't see any reply back. So we're not getting anything back from that Icmp request. So what we would like to do now, that was sent to vtc.com, and what that tells us is one of two things. Either there's no connectivity to that website, and the ping is the fact that we're not getting a ping response back is telling us that, or alternatively, there could be a border device such as a firewall or their external router that's blocking Icmp echo requests. And the reason you might want to block it will probably become apparent later on when we're talking about malicious packets. But the reason you might want to block it is that Icmp can be used for denial of service attacks, as we've talked about. So you might want to block those. There's no reason anyone needs to ping the inside of your network normally. So that can, by blocking it, you can stop potential attacks there. So let's go ahead and look at another set of ping packets where there is a request and reply. Now I've initiated a ping on an internal host on my internal network here, and we had to ARP out to find out what MAC address was used when I decided to ping it. But let's look at the ping request. We have the Internet Protocol header and the Icmp header. Let's take a look at those. Now again, version 4 of the Internet Protocol, header length, so forth. That's pretty much old news. We've seen that before. And the protocol Icmp. We've also got a header checksum, and we've got a source and destination address. Now let's look at the Icmp header itself. We've got the type 8 echo ping request, checksum, identifier, sequence number, and the data. And we've already seen from the previous capture what the data is going to be. It's just going to be the alphabet. Now let's see what the reply back to that information is. Let's go back up. Let's look at our IP header, source and destination addresses again, version, so forth. Again, things we've seen. Header checks out. Now let's look at the Icmp. Now whereas the Icmp echo request had a type of 8, for the reply we have a type of 0. A correct checksum, an identifier, sequence number, and so forth. Let's see what the data is. The data is the same, so it's going to send the alphabet back as a response. So we have this little conversation going on here where we have a request and a reply, request and a reply, request and a reply, a request and a reply. That's 4 transmissions and receipts. So we know that a Windows box sent this. If we saw a continuous echo request and reply, then we would suspect that either someone had used the -T in Windows, or this was a non-Windows box, a Linux box, Unix box, a Mac box, something like that. So actually when you're doing packet analysis, if you see these 4 little requests come back, you might suspect that's a Windows box. So that might actually give you insight as to who might be pinging you, what kind of platform they're using, just as an aside. So that's an Icmp header broken down for you. You can kind of see it's very simplistic. There's not much to it.